Hey, welcome back to another lesson in learning about microdevelopment. I'm your friendly neighborhood instructor, and in this one, I'm going to show you how we can use a 2D part editor to make some customizations to our products. So there may be some times where you want to add something to a part, like a custom cutout or something that's going to help your assemblers or even the installers as they get this job out to the job site. So let me show you what we can do when adding some machining to our parts in 2D part editor. Let's get started. Okay, so we're going to be working in this kitchen project again. I want to show you how Toolbox allows you to add some additional customizations or machining to parts that can be done on your CNC as they're getting cut out for production. First off, let's go into our micromelon palette under the Modify tab, go to Modify Parts, and draw a part in 2D. And select the part that we want to work on. In this case, we're going to use our tall right finished end. Now the product has to be drawn in 3D for you to do this. If it's drawn in just 2D, you're not going to be able to get this to work. So make sure you redraw your product in 3D first if they're not already. Now as we open up this interface, it's a new DWG file. On the right side, we have a new palette that opens up that shows you the parts of this local product. So here we just have those two right finished ends because this one's a weird one that has a bunch of different sub-assemblies inside of it. But there's our tall right finished end with the green lines representing some phase 5 machining. The holes also in green representing phase 5. We're going to talk a little bit more about phase 5 and phase 6 in this video, but more so in a later video coming up. You'll notice that you can also see the information of that part. So as you select it, see some of that additional information in there. The place pod and make G code, we're not going to go over that right now. So under the 2D Machining Tools tab, and here you have a list of all the tools that are set up in your tool file. So we have some vertical drills, some horizontal drilling, routing, sawing, even hardware too. So if there's hardware in your library that has some machine tokens already applied to it within that library, as you place that on your part, that machining also goes with it. So pretty cool little feature. But on this one, we're just going to be focusing on a simple round cutout. In a previous video, we talked about how there may be a water line or something behind this cabinet, and so we made an adjustment to our drawer subassembly. But now to make it a little bit easier for the installers, we're going to put a hole for that water line to pass through. So let's select that Routing Tools tab. As you scroll down, you have, again, all the tools that are set up in your tool file. But we're just going to pick on our default cutout tool, our 1/2 inch diameter. The depths you see in this column are coming in from your tool file, so whatever default depth is set up for that specific tool, that's what's showing up in this column. Everything right now is just set up to 0.25, so we're going to change that depth by entering a new value here. Just make sure that you're not going too deep, so you can verify the depth of that part just by looking on our screen here. That yellow border is representing the nested part, so see that 0.75 thickness, 19 mil. And if you want this to go all the way through the part, then it just has to match the thickness of that material. Checking this box makes it a phase 6 operation, and phase 6 meaning that it's actually on the side of the part that the machine can't touch. So as we're looking at this part right now, we're looking at it as if we were the machine and we're ready to route and drill some holes. If this were a phase 6 operation, it's going to be on that other side that we can't reach. So that requires putting that part back on after it's been cut. So if that doesn't make sense, don't worry, we're going to get more into that in a minute. But we're going to leave this box unchecked for now, go into our tool compensation. And the tool comp is which side of the route our tooling is running alongside of. This is the dado for our 1/4 inch back, and the tool comp is set to the right side of that routing line. As you hover your cursor over that layer, the layer name is the machining properties. It's a route with the depth of 0.27 and the RT representing the right tool comp and the tool number 103. And you can see this route a little bit different. Tool comp on the left side using tool 104. This Pick Existing Entities button allows you to pick something that's already on the screen. Now, not one of these things that we see here with these lines or holes, but something else that we would just draw manually with our AutoCAD 2D commands. So if we wanted a circle, we would use the circle command, draw that circle, and then pick that entity to apply the machining. But we're not going to do that. We're going to scroll down on the screen, and the bottom of this palette gives you a list of what we call machine tokens. So these tokens can be applied directly to the part, and they're coming in with some properties from Toolbox, letting it know whether it needs to be a round cutout, square, pocketed or not. Now when you pocket a cutout, it means that it's actually removing all the material inside of that cutout. What I like to say is just creating sawdust with that hole or square part that it's removing. Select the round pocket machine token, and now to draw that routing polyline, selecting the first point, and then giving it a diameter. We'll just make this a 2-inch hole. And that's what I mean by pocketing it. So the router bit or the tool is going to start in the very center and work its way out until it reaches that overall diameter of the hole. Now, this is definitely recommended when you have smaller cutouts. You don't want like a little 2-inch disc getting shot out of that part and flying across the shop. So it's always a good idea to use that pocketing feature with smaller cutouts like this. And once we have that done, we'll go back into our parts list. Make sure you select on the actual part that we were working on, tall right finished end. Right click and let it redraw inside of your project. Now that it's done redrawing, let's take a look and see what happened. All right, so it looks like it worked. We went all the way through the material. It should be a lot easier for the installers now to do what they need to do to pass that water line through. I also wanted to show you how we can work on another part inside of that local product. Now, because this one only has our tall left and right finished ends, we only have those options. But with that palette still being open, we can now select that tall left finished end, right click on that, and draw that part. Now what we've done is opened up another DWG file. So we have our tall right finished end and the left finished end, and both can have some machining applied to it. So if there was anything that we now needed to do to the left side, we could repeat those same steps of applying a cutout. One thing to make note of, it's not necessary to save these 2D part drawings. Once the machining has been applied to it, it's in the database and Toolbox knows what to do. So now let's go into part properties because I want to show you once we add machining to these parts, we can see it inside of the product itself. Select the tall right finished end. Now to the machining tokens tab, scrolling all the way down to the bottom, you'll find that new P-line 5 that was just created. So when you're working in the 2D part editor and applying the machining that way, all of the values are static values or hard-coded. So they're not formula driven or anything. The P-line 5 is not the typical cutout name of a hole or a round cutout, but that's how it shows up when you're applying it through the 2D part editor. And as you go into the vector locations and some of the other properties down here, you'll notice there's no formulas or anything. So just be aware of that. If you're expecting it to be parametric as the product changes, it won't be. But you can always just go back to the 2D part editor and move it around that way. Now let's have a little bit more fun with this one and now select that tall top. So this is a good example of when we see some phase 6 machining already assigned to a part. That machining is showing up in red. So we also want to be mindful if we're applying machining to a part that only has phase 6, if we apply a phase 5 machining operation through the processing, Toolbox is going to have to do something with that part, right? It's going to have to do its phase 5 first and then its phase 6, or it's going to have to figure out, can it do it all together? And I suggest checking out some of our other videos on the processing center and then how phase 5 and phase 6 machining works within Toolbox. So as I mentioned before, we have the option to pick some existing entities. So if we start drawing here with our AutoCAD tools, just a simple polyline, we can create any cutout we want. Just draw the shape, apply the machining to it, and that's it. And once you hit enter, that machining's been applied with the correct tooling. Now on this one, I don't want that tool to go outside of that line and leave just only that interior part. That's not what we're looking for. So all I need to do to change that is go into our route editing tools. Now, if I selected the right tool comp to begin with, I wouldn't have to go through this step, but we can reverse the routing polyline. That's this button here. Select that, and then select the polyline, and now you can see it's been reversed, going along the inside of that shape. Changing the set mill allows you to place the start of that route anywhere along this path. So rather than it dropping down in the corner and starting from there, I'm just going to pick this point here on this straight path. Now, the next thing to think about is how the tool is actually going to go into this part. So currently, it's just going to drop straight down, go 0.75 inches or 19 mil, and start moving along its path to cut away that material. Doing that to that tool is a little bit rough, so we can give it a lead in and a lead out so it gradually gets to that final depth. When we add our lead ins and lead outs, we have two options. We can do the ramp lead in with an arc lead. We can also just uncheck that arc and it would be a straight ramp lead in, which is just what it says, ramping down into the material. This one we have them both checked, so as we add the lead in polyline, pull the cursor over to the left-hand side, since that's going to be where it's leading in from, and we can just give it a value of 1. Now that tool is going to arc in from the outside of that path and ramp down to the depth of our route. And now as it goes all the way around and it's going to come back out of the material, we're going to add a lead out to the polyline, doing the same thing, selecting it, now dragging our cursor to the right-hand side and giving it the same value of 1. Now as we look at this part, this is how it's going to be nested on the machine. and we have the green representing phase 5 and red representing phase 6. So it's going to be on that machine 2 times, first with the phase 5 and then flip back over to do the phase 6. Now select the upper top in the parts list and update that current part inside of your drawing. Now this is just telling us that some of the Z values or the depths of the routes may have changed, so we just want to make sure that we're feeling good about the depths of these routes. Last thing you want is to go through the thickness of the material and into your spoil board, or even worse, deeper than that. Now there is a fail-safe inside of your tool file that shouldn't allow that to happen, called our router spoil board penetration, but just double check to make sure you're entering the correct value. If we now wanted to go back into it and maybe add some holes, we can do that. Let's select the first vertical drill, the 5mm. And just like our routing tools, we have to give it a depth. This time we are going to check the box to make it a phase 6 operation. We don't have any existing entities, so we can use the draw button at the bottom of that palette. Select the point, and then select another point, and then enter the distance in between holes. By default, they're coming in at 32mm, but you could change that to anything you want. We'll just leave it set up that way. And now we have a row of 5mm holes all spaced out at 32mm apart. Red representing the phase 6, so here we have some more phase 6 machining going on. And then another one that's going at a 45-degree angle. And this one will have the holes spaced apart 2 inches. So just like that, we have a routing operation happening, and we got some vertical drilling too. Going back into the parts list, select that part, and be sure to update the current part and redraw inside of your project. So I'm just going to isolate this top, and hopefully I can explain a little bit better on how phase 5 and phase 6 is working. So currently we have our through cutout, which is a phase 5, and the holes, which are on phase 6. Now because this product was built in a way that tells Toolbox phase 5 is inside of the cabinet, as we orbit around and look inside, we don't see those holes that we've added as phase 6. So there's our phase 6 on the outside and our phase 5 on the inside. Now phase 5, phase 6 doesn't always necessarily mean the inside or outside of a cabinet. It's just referring to how it's being nested on your machine. And just like that routing operation, as we go back into part properties, we can see those holes showing up as a machine token on that tall part. And down here we have our bore tokens, which are the holes. Now the 6 represents phase 6, where we saw on the P line 5, meaning that it was phase 5. And again, all those are static value and not formula driven. So the last thing I want to do in this video is show you how easy it is to delete one of these machine tokens that we've added through this 2D part editor or using our 2D machining tools. I'm just going to use that common tool number 101 again, give it a through depth of 0.75, and I'm going to select the square pocket, draw that routing polyline, just picking one point, dragging your cursor over, and selecting the second point. And there we have a square pocketed cutout. Okay, so there's our square cutout. Because it was applied to phase 5, we're now looking at it upside down, so it's in that bottom left corner on phase 5. I could go into part properties and delete it this way. A couple extra steps, opening up the subassembly, scrolling down, finding which token it is. So I could, if I knew which one it was, I could right click and delete that token. But a much faster way to do it when you're using the 2D machining tools is going back into that 2D part editor. Now I'm just going to close up this palette because it's going to want to open up a new one. And all I got to do is the AutoCAD delete command. So select it, hit delete, make sure you update your part. And it's that easy. Same thing, if I wanted to move something in there rather than deleting it, I would just open it back up again, use the AutoCAD move command, move it over a couple inches. Again, just updating that current part and redrawing the product. Now just a tip, don't delete any of the other machining that's going on with this part, only the ones that we've added or modified through the 2D part editor. Well, hopefully after watching this video, that helps you feel a little bit more confident in adding some machining to your parts before you send them out to production. Believe me, this is going to make your team assembling and installing your cabinets a lot happier. So be sure to check out more of these training videos and keep up that good work.